Here are a few matrix operations in the IML language. So suppose I have these matrices here. This is a 3 by 3. This is a vector, and here's another 3 by 3. If I use the diagonal function, it depends on what the matrix that you're running the function on is as to what it does. So if A, say, is a matrix, then x1 is going to take the values of the diagonal elements of the matrix A. So for example, the top left corner is 1, so x1 is going to be a 1 in the top left corner, and then the middle value is a 3, and then the bottom right corner is also a 3, and then all the other values will be zeros. So obviously the matrix that you're using in this diagonal function has to be a square matrix. So it'll create this function here. X2, on the other hand, if you enter a vector in as the object, then it'll take those values as the diagonal values. So 3, 4, and 5 will be the diagonal elements, and then everything else will be zeros. So if you want to do some calculations with some diagonal matrices, those are a couple of easy ways to set it up. You can also use these generalized inverse functions. That's the Moore-Penrose generalized inverse of B and C. You can also find out the number of columns in A. So obviously, since A is a 3 by 3, this is just going to have the value 3. It's just going to be a scalar. And you can find the number of rows similarly. M will give you a solver function. This will solve the equation A times M equals B. It'll solve it for M. Now, yes, you can in general say M is A inverse B. So you can solve this way, but if you got anywhere near any complicated matrices when you studied linear algebra, you'll know how complicated it really is, and it involves a lot of computing power. So this is a little bit more accurate way of doing that.